The straight line L has equation x minus y is equal to 3. The curve C has equation 3x squared minus y squared plus xy is equal to 9. We're told that L and C intersect at the points P and Q. We need to find the coordinates of the midpoint of PQ. So, we're going to work out the coordinates P and Q and then find the middle point of those. To find the coordinates of P and Q, we're going to do simultaneous equations because that's where the lines intersect. To do simultaneous equations, I either want to make x or y the subject of this first equation. I'm going to make x the subject because that's relatively easy to do. I can just add y to both sides. So x is going to be equal to 3 plus y, or y plus 3. So if x is the same thing as y plus 3, I can substitute y plus 3 into here instead of the x, and here instead of the x. So this equation is going to give me, instead of the 3x squared, I'll have 3y plus 3 squared. The y squared will stay where it is. And then we've got x times y, where the x has been replaced with y plus 3. So x is y plus 3 multiplied by the y, and we know that's going to equal 9. Right, let's deal with these brackets. Now, with this first set of brackets here, I know I need to deal with the squared before I deal with the 3 at the front. So let's leave that 3 at the front there for now. We'll come back to that in a minute. We've got the y squared. Y times y is y squared. We've then got the y times 3, which is 3y, but we need 2 of them, so 6y. And we've then got the 3 squared, which is 9. The minus y squared, I'm just going to copy that down for now. The second set of brackets, we've got the y times y, which is y squared. And then we've also got the 3 times y, which is 3y. And that's going to equal 9. Next, I'm going to multiply all of this bracket by 3. So 3y squared plus 18y plus 27. Whilst I'm at it, I've just noticed that I've got a minus y squared and a plus y squared here, so they're going to cancel each other out. I have got the plus 3y there, and that's equal to 9. Right, let's try and simplify this as much as possible, because I've noticed I've got the 18y plus 3y, which is 21y, plus the 27 equals 9. Now, this is a quadratic equation, so I want it to equal 0. So I'm going to subtract 9 from both sides. The 27 take away 9 is 18. Right. Now, one thing I noticed about this equation here is I can make my life easier by dividing each term by 3, just to make the numbers a bit smaller and easier to deal with. 3y squared divided by 3 is y squared. 21y divided by 3 is 7y, and the 18 divided by 3 is 6. I can now factorise this. It's going to be a y plus 1 and a y plus 6. So y is either going to equal minus 1 from the first bracket or minus 6 from the second bracket. So those are the y coordinates of P and Q. Let me now get the x coordinates. And I'm going to get those by substituting in to this rearranged version of the original equation there. So if the y is minus 1, minus 1 plus 3 is 2. Or if y is minus 6, minus 6 plus 3 is minus 3. Okay, so we have got the coordinates of P and Q. It doesn't matter which way round you write them. We can't really tell which one's P and which one's Q right now. Which is fine, because we now just want to work out the midpoint of PQ. So what's in the middle of these two coordinates? What's in the middle of 2 minus 1 and minus 3 minus 6? To do that, all you need to do, focus on the x coordinates first of all, add them together. So 2 plus minus 3 is minus 1, and then half it. So what we're saying here is that minus 1/2 is in the middle of 2 and minus 3. And now let's focus on the y coordinates. We'll do the same trick. Minus 1 plus minus 6 is minus 7, and then half it. So minus 7 over 2, or minus 3.5, is in the middle of minus 1 and 6. And so there we go. This coordinate here is the midpoint of P and Q, which is where the lines L and C intersect.